Hi, everybody. Today we're doing lesson 1 of Unit 6, Understanding Statistics and Sampling. So let's get right into it. We have some vocabulary here. Statistics unit is usually much more real world problem based. I think you're really going to enjoy it. This is going to be a very different kind of a unit. And it's a little bit of a break from the heavy algebraic type problems that we've been doing. So some of the terms that we use a lot are listed here. Data is information about characteristics of a group. When we talk about a qualitative variable, we're talking about something that's categorical. So it describes a particular characteristic, which can be divided into categories. We also have quantitative variables. Think of that word as having the word quantity in it. It describes a characteristic that is a numerical value that can be counted or measured. So keywords, I should say, counted or measured when we're talking about quantitative. Categorical is categories, obviously. A population is an entire collection of individuals about which we want to draw conclusions. So this is talking about everybody, all right? Versus a sample where we're talking about a select group from the population. A census, the collection of information from the whole population. A parameter is a numerical quantity measuring some aspect of the population. Now, for those of you that took Algebra 2 at Mendham High School, we definitely talked about population and parameter. So a parameter is a description of a population as opposed to a statistic, which is a description of something for a sample, right? So population and parameter both start with a P, sample and statistic both start with an S, so that should make it easy to remember. So a survey is a collection of information from a sample, and a statistic is a quantity calculated from data gathered from a sample. So we have an example. Identify the population and the sample in the below scenario. Administrators at Mendham High School surveyed a random sample of 100 of their seniors to see how they felt about the lunch offerings at the school cafeteria. So we want to identify the population. So in this case, the population is all the seniors at Mendham High School. And the sample is 100 seniors selected for the survey. All right, moving on. Okay, bias. A census is the most accurate way to investigate a population of interest. However, in most situations, it's impractical or impossible to obtain data from the entire population. Instead, we conduct a survey of well-chosen sample of the population. Errors can occur when a sample does not truly reflect the population we are trying to find information about. To avoid errors, samples should be sufficiently large and unbiased. So let's circle that. And what does the word bias really mean? Well, bias is the tendency of a statistic to overestimate or underestimate a parameter. All right, so let's look at some examples here. These are all examples, not really questions, just giving you some demonstration of what we mean. Suppose you are interested in the health of bees on a particular island. If you only collect data from 10 bees, you will not get a reliable idea of the health of all bees on the island. Right? So that would be an example of underestimating. If you only collect data from one particular beehive, the sample may be not representative of all the bees on the island. For example, the hive you pick may be stressed and preparing to swarm, whereas its neighboring hives may be healthy. The sample would therefore be a biased sample and would be an unreliable for forming conclusions about the whole population. So this would be underrepresented. Of the whole population. Number 2, an online survey is less likely to be completed by elderly people who are unfamiliar with technology. So in this case, this means that elderly people would be underrepresented in the survey. Another example, last one, in surveys on customer satisfaction, people are more likely to respond if they are unsatisfied. All right, so just a couple of ideas of how we can have a survey and there could be bias introduced. So right here, what I would do is I would pause the video and read these and then see what you think. And then when you're ready, restart the video. Number 1, we want to explain why each of the following scenarios are biased. A new drug called Cobrazole has been developed for treatment of high blood pressure in humans, a derivative of cobra venom. It is able to reduce blood pressure to an acceptable level. Before its release, a research team treated 7 high blood pressure patients with the drug, and in 5 cases, it reduced their blood pressure to an acceptable level. Is this a biased study? All right, this study is biased because the sample is too small to draw reliable conclusions. Number 2, a polling agency is employed to investigate the voting intention of residents in a particular electorate. From the data collected, they want to predict the election result for the electorate in the next election. A random selection of people in the local large shopping complex is surveyed between 1 and 3 p.m. on a weekday. All right, this is also a bias sample because we're underrepresenting full-time weekday working voters. All right, you're probably loving this lesson. No math, all right, just logic, common sense. Simple random sampling. In general, the best way to avoid bias when selecting a sample is to make sure the sample is randomly selected. This means that each member of the population has the same chance of being selected in the sample. All right, so I have a table here with some vocabulary for you. Maybe you want to highlight or circle keywords. For a simple random sample of size n from a population, each member of the population has the same chance of being selected in the sample. Each set of n members of the population has the same chance of being selected as any other set of n members. So basically the idea there, same chance being pulled out of the population. Systematic sampling, all right, there's different types of sampling here. Whenever you think about systematic sampling, think of it as a rule. A rule is used to select members of a population, for example, select every other person. Convenient sampling, only members of a population who are easy to reach are selected. Stratified sampling, a population is divided into smaller groups that share a similar characteristic. A sample is then randomly selected from each group. So we have smaller groups, and then a sample is randomly selected from each group. Quota sampling, a population is divided into smaller groups that share a similar characteristic, so smaller groups again. A sample is then specifically selected from each group. All right, so specific selection from each group as opposed to random selection. All right, on the next page, we're going to identify sampling methods. Again, right here, I would say just pause the video, read through them, give them a shot. All right, your answers are going to be either convenience or quota or systematic or simple random sampling. When you're ready, restart the video. Number 1, a chocolate factory produces 80,000 blocks of chocolate per day. Today, the factory operator wants to sample 2% of the blocks for quality testing. She chooses every 17th block. Well, we have a rule in place, so that one is going to be systematic. Number 2, an annual dog show averages 3,540 visitors. The catering manager is conducting a survey to investigate the proportion of visitors who will spend more than $20 on food and drinks at the show. He decides to survey the first 40 people through the gate. Well, that makes it nice and easy for him, doesn't it? Therefore, that is convenience. You randomly select 2 students from each classroom at Mendham High School. All right, so if we go back to our definitions, right, if you're picking from a group and it's random, that's going to be stratified sampling. As opposed to number 4, you specifically select 2 students from a group. So we're talking about specifically now. That guy is going to be quota. There are 200 students in the sophomore class. You assign each student a number from 1 to 200 and randomly select 30 numbers, thus randomly selecting the sophomores assigned to those numbers. That would be simple random sampling. And the last one, number 6, a library manager is interested in the number of people using the library each day. She decides to perform a count every 28th day of 1 year, starting next Monday. So again, this is a rule, so this one would be systematic. And have a great day. Thank you for watching.